Hi, I'm Paul Battaglia, and this is section 2.4, Complex Numbers. In section 2.4, we gravitate from polynomials and real numbers to complex numbers. So the question begs, how do we actually introduce the concept? So I'm joined by Gabe and Brittany, and I know, Gabe, you actually like to start off specifically with something, right? Go ahead.
Yeah, so just an example that I like to start off with is looking at the two equations, x squared minus 1 equals 0 and x squared plus 1 equals 0.
Good, yeah. That's a good idea.
The first one's pretty easy for students to go ahead and solve. They can solve it by factoring or just adding 1 to both sides and taking square roots, and they find x equals plus or minus 1.
Right.
But the second one, the x squared plus 1 equals 0, they might try to solve it the same way, but what they'll notice is, well, it doesn't have any real solution.
Or they might not even solve it and just say plus or minus 1 again.
Yeah. Or they might do that and say it's so similar, the answers are plus and minus 1.
Yeah.
But some of them might see it and say, oh, well, we'd have to take a square root of a negative number, so that means there's no solution. Right. Which is true when you're talking about real numbers.
Correct.
But we can segue and say, well, what happens if we do allow us to take square roots of negative numbers? Right. And that's where I go on and introduce the imaginary unit I.
And I think, what's interesting about that is what I would interject in my class at this point is, because, right away I usually get that, wait a minute, why do I need to know about imaginary numbers if they're not real, So then we talk from there about, okay, well, let's do some basic operations with imaginary numbers. And Brittany, what would you do with students to kind of just help them along to, I guess, ease the transition?
When adding and subtracting, I like to tell them that I is just a variable.
Right. And it's interesting because, they know x is a variable and a and b. And now, we do want them to look at I a little differently because of the concept, right? Yeah. But we don't want them to get too caught up in it, right? And so when we get into multiplication and division, Gabe, it gets a little bit more difficult, right? The terms are harder, conjugates, things like that. So
something that I've seen students maybe struggle with is when they're multiplying two complex numbers or two imaginary numbers. So for instance, if they're looking at the square root of -2 times the square root of -3, they might want to just jump into saying, oh, well, that's just the square root of 6 because it's the square root of -2 times -3, which is the square root of 6. And this is a good point to point out that that's only true when at least one of those numbers is greater than or equal to 0. Right.
And I think that's interesting because that's one of those times when students are making assumptions now. So, well, if I do -3 times -2, that's 6. I don't understand why, why can't that be? And so I think it's really important that they now are getting the concept of that I and what it means. Yeah. And I think one of the things you can do with your class also is when you're dealing with conjugate multiplication, and we've addressed the idea of what a conjugate is. The first thing we might do is we might harken them back to an earlier time when they were playing around with radicals, right? And so, Brittany, what would you do in order to get students to understand, what that word conjugate means? What might you just show them if you're sitting down with them?
I like to say, don't focus on the vocab, because sometimes, the vocab makes them nervous. And I would say, what we're really doing is, if it's a plus, then we're going to make it a minus sign.
Right.
And then we're going to multiply that by the original.
Right, and so then they're back to distributing, which I think is simple for them. If your students are struggling and they're not quite sure exactly how this conjugate thing goes, then you might want to even consider playing a game, and maybe you just get a random number generator either on a phone or online, or even I guess you could use dice, I suppose, and just have them generate two numbers, and let's say you put it into the complex form, so 7 plus 2i, and then tell them take the conjugate and multiply them. And you can make it a game. You can have them do 5 sessions of this and then compete against each other, and whoever gets the highest score wins. So nice and simple if you really need extra practice. But other than that, we're really still talking about basic operations here. Yeah. Right? I think the other thing you might want to think about with your students is perhaps flipping the classroom. I mean, if you have a class that can handle these operations without too much trouble, then maybe you start by asking them the previous day to go home and watch either a video you've prepared or perhaps read the textbook a little bit and go into the operations themselves. You can then answer questions the following day. Not a bad idea. One of the last things that we need to talk about is the use of the quadratic formula when it comes to complex numbers. So, Gabe, what do we want students to look out for?
Sure. So, when introducing the lesson, right after I talk about the x squared plus 1 and the x squared minus 1 equals 0 examples, maybe there's a good time to go just talk a little bit about the quadratic formula, because that is something that comes up when we're talking about complex roots. Right. So we're not always going to be looking at a difference of squares.
Correct.
We might have something that's going to have funkier roots.
Right.
But I think just teaching the quadratic formula, and it'll help us segue into the next couple sections.
Exactly, and that's the thing. As we start to find more zeros and use other techniques, they're going to need to understand that not everything is a real number. A complex number might come out of that quadratic formula for sure. So I hope these tips have been helpful for you, and you find much success in section 2.4.